Hi everyone, it's a pleasure to welcome you for this network scheduling class. This problem already I have done one problem where it is a deterministic problem in the sense that the jobs under consideration, or rather the project that we have taken, wherein the activities are deterministic. The project itself is a deterministic one in the sense that every activity has a definite time of finish. So you see that we can very well say that how much time it would take for the project to be completed, having known that the every activity has got a definite days of finishing. Okay, you see that. But here this is slightly different, and this is a probabilistic project. This is a probabilistic project in the sense that we do not know, we may give a tentative time of finish of the of every activity, and hence it will result in a tentative days of finishing the project. And but there will not be widely fluctuating, I should say, in the sense that a tentative date means it may be 5 days, means it may not go 10, 15, 20 like that. It will not be like that, but definitely there will be a difference because it is a probabilistic because of various reasons. I'll tell you what it is. Here you see that this is a project. This is a probabilistic project, and you are given. I'll straight away come to the problem and explain each and every aspect as I deal with the problem. Okay. Now you see that here there are 9. This is a project with 1, 2, 3, 4, 5, 6, 7, 8, 9 activities, and the every activity, it unlike the deterministic project, here you see that there are 3 time estimates for every activity. Okay, now say that this is A, that means A is it is optimistic. It is A is optimistic time estimate. It is an optimistic time estimate. M is most likely time estimate, and B is pessimistic time estimate. In a sense, I will explain each and everything. So you see that, let me come to this pessimistic time estimate. Pessimistic time estimate in the sense that pessimistic time estimate. Pessimism means hopelessness, I should say. The straightaway meaning is that it is hopelessness. You see that pessimistic means not optimistic. That is, there may be chances of facing lot of difficulties before on execution of an activity. So you see that here you can find that this particular, for this 1 to 2 activity, if it is optimistic in this, let me explain this. So you see that there is a chance that you may require a loan for that particular activity. You are expecting a loan for that particular activity. It is getting delayed, or the men you have employed are not coming in time, or they are absenting, or less number of people come, and that you see that likewise, or because of various other conditions we do not know, various other untoward unexpected conditions may come that may delay, that is probably will delay this activity, because of which you see that I will be able to, there also you give a timing that it may take a longer period of 13 days. Okay, now come to this opposite one of this optimistic time. Optimistic means you are very confident, optimistic, you are very hopeful, and you are a positive person in the sense that everything comes in your way, that when you do something you get a result, or that when you want money, you get the money, and you want persons to help you, you get the persons. So you see that everything assists you, that you confidently say that I will be able to finish in short time, a specified short time. Whereas here you see that pessimistic time will always be greater than the optimistic time. And that most likely time means it is most likely in the sense that sometimes your expectations does not come true and some do not come true, and sometimes it comes true in the sense that you expect the money, sometimes it does not come, but it comes after say 1 or 2 days. That means it is not getting delayed too far, that you are able to do the job without much of difficulty, as in the case of, unlike in the case of B, that is pessimism. That okay. Now you see that. So you see that this optimistic time means everything assists you. Whatever you want, the things assist you. The environment assists you. The loan that you want assists you. So many, everything is assisting you, that you say that you will be able to finish it in a short time. Whereas in the case of pessimistic time, everything is acting against you, that you have become pessimistic, and you give a very dejectedly, you say that I will be able to finish it only after so many number of days. Okay, but most likely means that you are getting in time, sometimes you don't get, but it is not giving you much problem. So you keep your day, the number of finish of the particular activity in the middle. So you see that in the middle, or some it is coming in between one and the lowest and the highest. So it is given to be 7 here. Likewise, you see that the time estimates are given. So there are 3 time estimates in a probabilistic network project. It is optimistic time, pessimistic time, and most likely time. Now with this, you see that I cannot work out the problem with these 3 estimates. How to work out? So you see that for a single activity you require, I want just like a deterministic project. Every activity has got a definite time. So here also I must have a definite time. So that definite time is given by, that is, this is called your TE of I to j. That means the estimated, the average, probabilistic average. It is called what? A probabilistic average of the every activity. Tij means what? The time duration of every activity. It is a probabilistic average. Okay, that is given by, it is like this: A plus 4m plus b divided by 6. So this is the formula that you use for finding the average length of time for every activity. So you see that for this activity I will get TE from 1 to 2, TE for 1 to 6, TE for 2 to 3, like that it goes up to TE for 7, 8. So you see that given 3 time estimates for any activity, we can always get an average time that is required for completion of that particular activity, which is given by this formula: A plus 4m plus b, where A is the optimistic, this is pessimistic, and M stands for most likely. This is actually for every activity is given like this. Okay, now let us stop with this. Then you see that whenever you talk about probability or samples or something like that, you must necessarily talk about the average, talk about the variance, talk about the standard deviation. Standard deviation is nothing but the average spread, from the mean. The average spread from the mean is nothing but your standard deviation, and the square of it is nothing but your variance. Okay, now you see that for this you have to find, therefore you have to find the variance for every activity, because as I told you, if there be a probabilistic or a statistical average, naturally there must be a variance, and it is followed by a standard deviation. So you see that here you must have an average. So I have got the probabilistic average. So there must necessarily be a variance. So this variance, we give it as variance of I to j is equal to, this is given by b minus a divided by 6 whole square. So this is given like this. B minus A. B is nothing but pessimistic and this is optimistic divided by 6 whole square. So this is nothing but your sigma square. Sigma of what? Sigma square stands for variance. This is for I to j. Therefore, your sigma I to j, which is nothing but standard deviation, which is equal to B minus A by 6. This will always be, see, this is a positive quantity. So this is your standard deviation. This will be a positive quantity. So you see that with these, draw the project network, calculate the project length, find the latest time for all activities, and find the probability that the job can be completed in 40 days, and the second question is 35 days. So we are going to answer these questions one after the other. So you see that for this necessarily you should prepare a table. The table must contain your TE for every activity and sigma squared I to j for every activity and sigma ij standard deviation for every activity. That is very, very important. So you see that we will start, and before that you see that I will draw this. Without all this also you can draw the network diagram of this. See what is given here. See 1 to 2. So it goes like this. It goes like this. 1 to 2 starts. So it is 1 to 2. I will put here. It starts from 1 to 2. And it is 1 to 6 is a bit long. You can just put it like this. It is 1 to 6. Then 2 to 3. Then 2 to 4. Then 3 to 5, then 4 to 5, 4 to 5, 6 to 7, then 5 to 8, I will put it here, 5 to 8, then 7 to 8. Now you see that, see whether you have drawn it correctly. 1 to 2, then 1 to 6, 2 to 3, 2 to 4, 3 to 5, this is your 5. Then 3 to 5, then 4 to 5, 6 to 7, 5 to 8 and 7 to 8. So this is the very simple network diagram we have drawn. Now I have done this, I have done one problem in the deterministic deterministic network problem. Here you see that I have taken this probabilistic one, and you see that for this 1 to 2 you have to find TE. So find TE for this, find TE for this, find TE for this, find TE for this. For everything you must find TE, and we will start doing this. So you see that I will write here. So it is it's a big one, so you write this activity. It is activity. Then we will take this as, see, I will straight away write this. T is equal to A plus 4m plus b divided by 6. Then you write this is what you have. Then your what is that you want? Earliest start time, earliest finish time we can get. You see here, let me first finish this. So you write this activity, then sigma square is equal to b minus a by 6 whole square sigma. So it is 1 to 2. Just straight away write these figures. You see that here I use this sigma 1 to 2, here 1 to 2 will be 7, then 1 to 2, 1 to 6, 2 to 3, 2 to 4, 3 to 5, 4 to 5, 6 to 7, 5 to 8, 7 to 8. Now you'll see that this is 6, then it is 14, 5, 11, then 7, 11, 4 and 18. So you see that these are the values that you get using this formula. For example, you see that for the first one I will do it for 1 to 2, t of 1 to 2 will be a plus, see, a plus 4 times of this will be 28 plus 13 divided by 6. So this is equal to 2242 divided by 6, that is equal to. So I am getting 7. For the third one I will do, see what is your T23? What T23 is here, 4 into 5 for 56. So 2 plus 56 plus 26 divided by 6, that is 14. So I am getting 14. So this is the way you calculate. So by using this formula I am able to get this. So you see that this is over. So you use this formula to get this. So use this formula to get the values of this, and likewise I will get sigma squared. It is 4 and it is 4. This is 16. Then this is 1, this is 4, this is 4, and this is 16, this is 1, and this is 16. So you see that here again, you see that 13 minus 1, 12, 12 divided by 2 is 2, 12 divided by 6 is 2, and that whole squared is 4. So can you catch this, what I am writing here? So you see that here, see 13 minus 1 is 12, 12 divided by 6 is 2, 2 whole squared is 4. Come to this, 14 minus 2 is 12, 14 minus 2 is 12, 12 divided by 6 is 2, 2 whole squared is 4. Come to this, 26 minus 2 is 24, 24 by 6 is 4, 4 squared is 16. Likewise everything is calculated. Now what is your sigma? This is your standard deviation. This is 2, this is 2, this is 4, 1, 2, 2, 4, 1 and 4. So this is what we get, and you see that, so this is, I hope that all of you can understand, it's a very simple calculation, and drawing this network is also not difficult because it is very easily given that one can understand and do that. So you see that this is how you get. Now let me start let me start marking the weights in the sense the days, by how many days the activities are likely to get finished. So you see that, suppose you take this, for this 1 to 2 it is 7 days. So you see that 7 is called the weight. So for 1 to 2 it takes 7 days, and 1 to 6 is 6 days, 1 to 6 is 6 days, 1 to 6 is 6 days, and 2 to 3 is 14 days. This is 14, and 2 to 4 is 5, and 3 to 5 is 11, and 4 to 5 is 7, and 6 to 7 is 11, 6 to 7 is 11, and 5 to 8 is 4, and 7 to 8 is 18. So you see that these are so given A, B, C and everything, we are able to calculate the T, the average time of finish of every activity, and this is what we get. So you see that as such, you see that draw the project network. Yes, I have drawn the project network. How could I draw the project network? Keeping this network schedule. Another thing is that find the after then I am able to find the average time of finish for every activity and the variance of every activity, and subsequently this standard deviation. And you see that I mark this average time of finish of every activity over here. Now you see that as I have taught you, if you have not, it is, you just go through my previous deterministic problem, you will find it, you will find and you can understand. And now if you have gone through that, you will be able to understand better what I teach you now. Now you see that here when it starts, its earliest time is 0 and latest finish time is 8. This is your earliest start time, this is your latest finish time. So you see that your earliest start time is 0 and latest finish time is 0. Now 1 to 2, it starts at 0, so 7 plus 1 is 7. And you see that it is after then, you see that you come to this, there is only one way. 7 plus 14 is 21. So put a line this. Then come to this. 7 plus 5 is 12 because there is only one way. And coming to this 5, 21 plus 11 is 32. Whereas if you can't take this 4 to 5, it is 12 plus 7 is 19. So you have to take the maximum of this. Here you see that 3 to 5, it is 32, and 4 to 5, it just takes 19. So between these two, which is your maximum? This is your maximum. 32 is your maximum. Mark that. Then we will come to this. So there is only one. As long as there is only one way, you need not bother. Only when you come to a junction, you have to decide, you have to take the maximum of all the ESTs, the earliest start times, leading to that particular node. So you see that this node is a junction, this node is not. So as long if there is a junction, you have to be very careful. Now come to this, 6 is here, so 0 plus 6 is 6. And come to this, there is only one path, so 6 plus 1 is 17. This is 17. But coming to this 8, there are two paths. 5 to 8 is another one path, and 7 to 8 is another plus. Now you say 32 plus 4 is 36. And this is 17 plus 18 is what? 35. But that is 35 is smaller than 36. So you put it like this. So your earliest start time is and latest finish time. So this is what you get here, 36. Now you come back, you trace back. Now you see that when you trace back, 36 minus this will be 18. Okay, so there is only one way, so 18. When you take this, 36 minus 4 is 32. And then when you come back here, you see that 32 minus 5 is 25. Then when you come back here, you see 32 means it is again 21. Then you see that from here 25 minus 5 is 20. 21 minus 14 is 7. So you have to take the minimum. 25 minus 5 is 20. Whereas 25 minus 5 is 20 only for what? 4 to 2. Whereas you see that it is 21 minus 14, that is equal to 7 for 3 to 2. So you see that between these two, for 7 and 20, you will take the minimum. Therefore this is 27. And come to this is 18. 18 minus 11 is your 7. So 18 minus 11 is 7. So 7 minus 6 is 1, whereas 7 minus 7 is 0. So you will take the least. So this is the see, we have marked the earliest start time and the latest finish time. Now you can talk about the floats and everything, but floats have not been asked in this problem. That is why I am not doing it, but I am able to get what? Earliest start time and latest finish time for all activities I have got here. So this is what I have done here. Now, so this is also over. So what I do here is that, so you can just say that, so your earliest start time you can write, I'll write at the end, after finishing I'll write. So you see that your earliest start time and latest finish time of every activity, and this will be earliest start time and latest finish time. You'll have earliest start time, and this is, I will write earliest, see, earliest start time, finish time, latest start time, finish time. So what is that you have got here? So your earliest start time is here. Here you see that your earliest start time is, here you put it as duration. Duration, it is activity. Here you have got the activities here. So 1 to 2 you have got your activities here. So it starts at 0, the duration is 7. It starts at 0, so it starting time is 0. So 0 plus 7 is 7, and it finishing time is 0. 7 minus 7 is 0. Then your 1 to 6, where is your 1 to 6 here? Its starting time is, see how, what is the duration? 6. It starts at 0, so 0 plus 6 is 0. What is the latest finish time? 7. So 7 minus 6 is 1. Then you go for what? 2 to 3. 2 to 3. What is your 2 to 3 here? It is starting at, say, duration is 14. Duration is 14. It starts at 7. So 7 plus 4 is 21. And it is latest finish time is 21. 21 minus 4 is 7. Then you go to, what is that? 2 to 4. 2 to 4. 2 to 4 is here. Its starting time is, duration is 5. Its duration is 5. When does it start? It starts at 7. So 7 plus 5 is 12. And its finishing time is what? 25. 25 minus 5 is 20. 20. And come to this 2 to 4, 3 to 5. So what is your 3 to 5? 3 to 5 is here. What is the duration? 11. And it starts at 21. 21 plus 3 is 32. And you see that 5. What is the latest finish time? It is 32. So 32 minus this will be 21. And come to this 4 to 5. 4 to 5, 7 days. So it starts at 12. 12 plus 7 is 19. And its finish time is 32. 32 minus this will be 25. And you come to 6 to 7. So 6 to 7, where is your 6 to 7? It is 11 days. And it starts at 11 days. And it starts at when? It starts at 6. It starts at 6. So 11 plus 6 is 18. When does it finish? 18. So 18 minus 11 is 7. Then 5 to 8. 5 to 8, 4 days. When does it start? 32. 32 plus 4 is 36. When does it finish? 36. 36 minus this is 32. And your last one, 78. 78. How many days? 18 days. It starts at 17. This is 35. It finishes by 36. 36 minus this will be 18. So you see that I am able to get the earliest start time, finish time. Latest, this is latest. So latest I am able to get that 0, everything I got. So this is the question. Find the latest finish time and the of every activity. This is what you should get. That is, I have written earliest start time and finish time and latest start time and finish time. Using this, you will be able to find all the floats, total floats, free float, independent float, and there is one more interference float is there. So all these things can be calculated using this. Since that has not been asked, I have not done in that. So you see that here total float means, now you see that here you can observe one thing, that here total float, see you can just see, I will write only total float. Total float is nothing but what? Latest finish time minus earliest finish time, latest start time minus this. That means latest finish time minus earliest start time, latest finish time minus earliest finish time, or latest start time minus earliest finish time. So 7 minus 7 is 0. So you just see that here you come to this place, you see that which one will you get, and you just see that there are nodes which have both earliest start time and latest finish time equal. Can you see this? It is 0 0, then 7 7, 21 21, 32 32, and then 36. That means here you can see that this is your critical path. That means what? This is your critical path. See, I will write here, this is your critical path. So this is your critical path, this one to this one to this, and this one to this. So your critical path is what? Critical path is 1 to 2, 2 to 3, 3 to 5, 5 to 8. And what are how many number of days? 7 plus 14 plus 11 plus 4, that is 15, 29, 36. So how many days? So that this is called your expected average, expectation of the expected finish time. You know why I use this expected word? Because this is a probabilistic problem, that every given this here 4 is not totally determined. It need not be 4 because there is a variance. You can just see that what is the variance of this. Here you see that for the first one the variance is 2, means the standard deviation is 2. That means this 1 to 2 work can be finished in 7 plus 2 9 days, or it is 7 minus 2 5 days. So the range is between 5 and 9. Can you understand? So you see that these are the understandings. So many understandings are there that we have to only for you, these things are required. That is why I teach you only this. So you see that this is called a probabilistic average. So the expected time of finish of the project TS will be 36 days. It doesn't mean that 36 days, because I will tell you what it is. Okay. Now for the time being, you take it from me that this TS is equal to 36 days means it is the probabilistic average, or on an average it may take 36 days. 36 days is not a deterministic one. Take it from me, because all the activities are probabilistic. Hence the overall finish time of the project is also probabilistic only. Okay. Now, so this is what we have. So I have written everything here. So what is that? I'm going to take the last one now. Just see that what is that I have taken here. I have used the formula, every activity is probabilistic, therefore it has got 3 time estimates: optimistic, pessimistic, and most likely. And for every activity there must be one average activity which is the average of all the 3, but the average is given by A plus 4M plus B by 6, where A is optimistic, B is pessimistic, and M is most likely. Using this formula, I am able to get one time estimate for all activities. And as I told you that if you talk about probability or statistics, statistical samples, this and that, you have to necessarily ask what is the variance, what is the meaning, what is standard deviation. Because you see that if you take an average, there must, if you say that there is an average, then naturally there can be a deviation from the average. And for the timing for this problem, know that you have to find the sigma squared and also the standard deviation of every activity. And having calculated that, you have to, I have taught you in the deterministic problem how to calculate the earliest start time and earliest finish time. Likewise, latest start time and latest finish time, I have taught you just now how it is done. So using that, you do this, your problem, your drawing the project is over, calculate the project length is, what is the project length? This is, and you must know that there is one more name for this. I should tell you this very important, because you find that for this this one you will find that this, I will put it in green ink, that 1 to 2 and 2 to 3, here 2 to 3 is here, for 2 to 3 also it will become 0, and for 3 to 5, for 3 to 5, 1 2 3 4 5, 1 2 3 4 5, so for this also 0, for this also 0, and 3 to 5 and 5 to 8, 5 to 8 is this. So you see that this will be free float and independent float, all will be 0, all will be 0. Here you see that for the critical activities all will be zeros, in the sense that that activity cannot be delayed for any reasons. You cannot delay that activity, performing that activity without that is, you cannot delay that activity. That is why you see that total float, everything. Therefore a critical path is nothing but a path of 0 total float. It is called a path of 0 total float. So the total float for all activities will be, critical activities will be 0. So the critical path may also be termed as path of 0 total float. It's a path of 0 total float. So that is how we say. So we have seen all these things. Now I will come to the very important one, which is nothing but find the probability that the job can be completed in 40 days and 35 days. Now let me rub off this. I want only these two here, so I will go for this. So you see that before doing this, I will rub off this. See the variance, see. So you see that we are very much bothered about only the critical activities, in the sense that critical activities have to be completed. If you delay, it will cause a lot of problems. That is, in the sense, it will create a lot of hardships for you in the way of completion of the project, or the that is cost escalation, and everything will come up. So you see that you will not delay the critical activities. Now you see that the critical activity, this one critical activity is here 1 to 2, 2 to 3, 3 to 5, and 5 to 8. So these are the critical activities, and for this critical activity you have got, see here, 1, 2, 3, 5 and 8, and for this it is 7, and it is 14, and it is 11, and it is 4. So this is 15 plus this is 29, 36, so this is so TS, the expected finish of time, the expected finish of the project is equal to 36. So the total number of days the project is supposed to be completed is 36 days. It may take, and not necessarily, as I told you, 36 days means not necessarily 36 days, because again it is a probabilistic one only. Here and there you see that we are going to, what is the standard deviation for that? How do you calculate this? Now you go for this sigma squared of critical activities. What is that? You take the sigma of this, sigma of sigma squared critical activities. What is that? It is 7. Sorry, here it is 2. So 1 to 2, you just see that 1 to 2, then 2 to 3, 1 to 2, then third one is 4, this one, I'll not put this, then 2 to 3, 3 to 5, 1 2 3 4 5, 1 2 3 4 5, so this one, then 5 to 8, 5 to 8 is last but one here. So these are the variances that we have got for the critical activities. So for this, the critical activity for sigma squared is here, it is, see that sigma squared is 4, Here the sigma squared is 16. Here the sigma squared is 4. For this the sigma squared is 1. So you see that we have got the sigma squared values here. So you put that as add them. So you see that sigma squared is 4. 4 plus 16 plus 4 plus 1, that is equal to 25. So you see that this is the whole sigma squared of the problem. Sigma squared of project is equal to 10. Therefore, standard deviation is equal to. Take only plus. So what is the standard deviation? What is the meaning of that? So you see that the average, probabilistic average 36 days. So it may take 36 plus 5 days, 41 days, or 36 minus 5, 31 days. So it will range from the average finish of the completion of the project will range from 31 to 41. Can you understand? 31 to 41. So you see that this project at the least, at the earliest 31 it can get finished, or at the highest value it may take 41 days for the completion of the project. That is the meaning of that. Okay. Now I hope that you are able to understand how to get the variance of the project. This is called the variance of the project. Can you understand? I have written here. This is called variance of the project. I'll write here sigma square of the project. This is called your variance of project. This is called variance of project, and it will take 25 days, and its standard deviation is 5 days. So this is all our understanding about this. Keeping this in our mind, we will start doing this particular problem. So you see that now I no longer require this, so I rub off this. So you see that. Now what is that you want now? Now we have to find what is 1. What is the probability that your T is, I will put it like this, TS. So TS, this is your T. Actually this is your T. This is your T. This is your T. Yes. This is your T here. The expected time of finish of the project 30. So TS is given. What is TS? Here TS is given. TS is given. So you see that you change it to standard normal variate as Z is equal to TS minus TE divided by 6. So changing this to standard normal variate, then we go to the standard normal curve. You see that it's a Gaussian curve. Using that Gaussian curve, we will be able to determine the value of this. Are you able to catch what I am telling you? So you see that you are asked to find TS. TS means what? The question, what is the probability that it can be finished in 40 days? So this TS is your given 40 days. Now change this to standard normal variate form, and then go to the normal distribution curve, and using that curve and referring to the table, I'll tell you the table, I may not be able to show here. Go to the table and you will find the values. Take those values and put it here. You will get the answer. So you see that this is nothing but what? So this is TS. So this is equal to Z. So this is Z less than or equal to, this Z is nothing but what? TS minus. TS is minus. So this TS minus T is divided by sigma is less than or equal to 40 minus 36 divided by 5. So this you call it as your Z. Z is less than or equal to, it is 4 by 5, that is equal to P of Z less than or equal to 0.8. So you see that given TS, I will be able to change it to normal standard variate as P of Z, where Z is equal to Ts minus Te divided by sigma, and this is less than or equal to 4 by 5. And now you see that you have got this. So what I will do here is, I will draw the normal distribution curve here. Normal distribution curve is this. And it is almost grazing over this x-axis, and you see that here is z-axis, and this is what you get. And here you see that is minus infinity, plus infinity, 1, 2, 3, 4. And here you see that equal length 1, 2, 3, 4. 4, 3, 2, 1. 0, minus 1, minus 2, minus 3, minus 4. So you see that between this minus, so you must know that here between the area between this z axis and f of z curve, this is your f of z normal distribution curve, between this the area is 1. The area between this z and this f of z is 1, and the whole area gets fully got into the range between minus 4 to plus 4. Almost minus 4 to plus 4, you get all the values that it is 99% of the values would come here. Balance of it, some little value will go beyond this minus 4 here, and it is beyond this plus 4. And that if you keep them, they are symmetrical. Here the symmetrical in the sense, whatever happens, whatever you want to study on the left hand side can be studied on the right hand side. Can you understand? And that here you see what we do here is that, so now you see that here P of Z is equal to 0.8. You just find out where is your 0.8. 0.8 will be somewhere here. Okay, so this is your 0.8. So you draw a vertical line like this, ordinate like this. Now your probability is nothing but the value of this will be from the left hand corner minus infinity, all these things start from minus infinity, shade everything here, you shade everything and come to this value. This whole value starting from minus infinity to 0.8 will be your probability. Can you understand? So this is how we calculate. So I'll repeat this once again. So you see that once you are asked to find P of Ts less than or equal to 40, then convert this to your standard normal variate using the formula Ts minus Te divided by sigma. And Ts, you know, it is given to be 40. Ts is given to be 40. Ts, here it is like this. Ts is equal to 40. Te you have found it to be 36. Sigma is equal to 5. So what is the probability of Ts less than or equal to? So this is the problem. So given Ts is equal to 40, T is found to be 36 and P also have to found to be 5. You see that 5. What is your this one? That is what I am finding here. So you change it to normal standard variate as this, and it is equal to Z less than or equal to 4 by 5. It is 0.8. Now he said that this is a normal distribution curve, and this is a curve, this is S and f of Z, and this is a curve, and it is a bell-shaped curve, and you will find that it extends from minus infinity to plus infinity, and the value of this area is equal to 1, and the whole of the values is between it completely comes between minus 4 to plus 4. After then only a small value comes. That is why we stop here at minus 1 to minus 4, and that so many other things are there which I only when we take that subject I will be able to tell. For the timing for this situation, this is more than enough. So you see that it is minus 4 to plus 4, everything comes, and you see that here you want Z is equal to 0.8. So you go to this 0.8, draw an ordinate there. Now your probability, the value of this will start from minus infinity to 0.8, and you must know that this is symmetrical, that the area of this is 0.5 and area of this is 0.9. That means the whole area is 1 and it is symmetrically divided by the f of z axis, that is z is equal to 0 axis. Here 0.5 and there 0.5. Now you stop at 0.8. Now you calculate the value from minus infinity to 0.8. That means, so this will be equal to 0.5 plus probability of 0 less than or equal to z less than 0.8. Now you see that this value I will just give you. You just go through this. You go to the table. And you go to that z column 0.8 and immediately 0.80. You go to the next mean difference 0. You will find some figure. That figure I am writing here. So this is 0.8. Value of this 0.8 I will give you. It is equal to your it is 0.528 point. It is 0.2881. See, it is like this. So this is equal to 0.7881. Therefore, the percentage of completing the project in 40 days is equal to multiplied by 100, you will get. So 78.81% that this project can be completed in, for that means what? Very well you can complete. There is no doubt that you can complete the project in what? 78% completion is possible. So 40 days you can very well say, you can give an assurance to your customers that it will be finished in 40 days. Nothing to worry on that. So this is how we will calculate the first one. Next one I will do. So the next problem is, see, this is the first one. The second one is, so the next one is TS is equal to, it is 35, T is equal to 36, your sigma is equal to 5. So T is equal to this one. So what is the probability of ZT TS is less than or equal to 35? So this is what, see, TS is equal to 35, this one. So find P of TS. So this is the question. See, you are asked to find P of TS less than or equal to 35. We having known the values of TE, the probabilistic completion of the project 36 days, and it is the standard deviation of the critical activity is 5, and now P of TS less than or equal to 35 is equal to P of TS minus TE divided by sigma less than or equal to 35 minus 36 by 5, that is equal to P of Z less than or equal to minus 0.2. So you see that now I should find what is the value of this using this Bell diagram. Can you understand? So after coming to this, go to the Bell diagram and find out what will be the value. You just see that. I'll draw this again. So this will be like this. So if you come to this, see, it will be as I told you, this is symmetrical. This is Z, f of Z, 1, 2, 3, 4. Equal length, this is 0.5, and you want 0.2 is here, see, This is 0.2. Now you want the area like this. So what is the area that you want now? So this is your area, and I told you that there are certain you can directly you can get you have the tables for getting it directly, or the other way of doing it is that you just keep a mirror here, it will get reflected. That means what? This is symmetrical about that Fy, Z is equal to 0 axis. So whatever you want to study on the left hand side can be studied on the right hand side. Just keep a mirror, it will get reflected. That means this 0.2 line will come over here and lie here. Because you see that the image is as far behind the mirror as the object is in front of it. That is same meaning. So you see that this is here means this is also at 0.2. So this is also at 0.2. So it is minus 0.2, it is plus 0. That's all. But your shading is to the left here, your shading is to the right here. So this is what we want. So you see that this is. So we want this area. So this area is getting reflected on the other side. So instead this area we have to find. So instead of finding this area, you find this area. But what is this area? So this is nothing but 0 whole area in 0.5 minus P of 0 less than or equal to Z 0.2. So from the whole area you take away the small portions. Can you see this? See this portion. So this 0.2 it is like this. See, I've got here the 0.2. So this is your 0.2 area. 0 less than or equal to Z less than or equal to 0.2. This is the area. So you take this 0.5 and refer to the table for 0.2. Subtract that, you will get the answer. So 0.2 it is given to be, your 0.2 is given to be, it is 0.5 minus 0.0753. Now subtract, you will get yes, 0.4257, that is equal to what? 42.47% probability of. So you see that probability of finishing this in 35 days is not even 50%. Is not even 50%. What does it mean? You cannot give an assurance. You see that the probability is less. Probability of finishing. Suppose if you ask for 20 days like that, you see that the probability will be still lesser. Can you understand? So you see that here this using this Gaussian curve or the normal distribution curve, we will be able to find out the probability of finishing the project in a particular time. You see that in this case it is less than 35, the probability is only 42.47. So this is how we calculate. And in this particular probabilistic project problems, the very important one is this one, finding the probability of finishing the project within a certain period of time. That is very, very important. And that here you have got 3 time estimates. Finding one time estimate is important, finding a variance is important, and sometimes you may be asked to find the floats also. I have given an elaborate explanation about the floats and everything in my video where I have taught this deterministic project. So these are the things that you should know, and I will do more problems in the coming days in taking